Today we're going to move forward, and our ultimate goal today is to be able to find the area of a trapezoid. And before we even start that, I gave you graph paper yesterday. I want you to draw a trapezoid on your graph paper. Now if you need, because you're going to want to be able to cut it out and have straight lines, rulers are over there in the drawer. I would recommend you get a ruler, maybe have one person from each row to get enough rulers for everybody in the row. And because you're going to cut this out, I draw my trapezoid big enough that I can actually work with it and cut it out and be able to do what I need to do. You have to get some what, Bryson? Do you have your notes, the packet? Do you have the packet that they collected for you? They should have had a piece of graph paper with it. So draw a trapezoid big enough that you can cut it out and have something to work with on your graph paper. Don't cut it out yet, just draw it. Do you have it now, Bryson? Okay. Everybody's drawing the trapezoid using straight edges so that they'll be straight, because they really need to be straight to be able to do the activity that we're going to do. And it doesn't have to be like this one exactly. Draw your own. Just make it big enough on your graph paper that you will be able to cut it out.
I forgot what a trapezoid is.
Well, there's a picture of one on your notes and also on the board. You should have out your notes as well as the board, or as well as your graph paper. There's a picture. Nobody's cutting anything out yet, we're just drawing. It did recommend that you made sure that your base, that both the top and the bottom were on one of the lines of the graph paper so that you can have a definite top and bottom. Okay, that'll work. When you get it drawn, then, and we're not cutting or anything yet, once you have it drawn, you're going to want to draw a line that shows, oops, I have this, okay, I'm giving it, we got to get it, I think it got bumped.
Wait, no.
I can't see. Okay, once you've got it drawn, you're going to want to draw that straight line that indicates where your, I need to lock that one in, too. Where your right angle is, or where your height is. Okay, because you're going to want to, it says here, estimate the area of your trapezoid by counting the unit squares in your drawing. So you're going to count the number of units squared in your drawing. Do you understand what I mean by that? Okay. I'm just going to go up here and I'm going to look and I'm going to go, well, there's 1, 2, 3, 4, 5, 6, 7, 8. I'm going to count all the squares. So I'm counting an estimate for the area of the shape that I've drawn. And that they are going to be different because everybody drew their own thing, right? So start counting. Okay. Write down maybe somewhere in the middle or something what your estimate is then. Now, some of your squares aren't full squares, are they? Okay. So you may have to kind of see, you know, if I got a half of one here, do I half of one over here, I can count that as a whole. You know, because this is an estimate. What, sir? I would put a broken line down the center of it, or down wherever you've got your height, so you know how tall it is, because we know we're going to need it later. Okay? And let's see, I need that paper copy, because then I can estimate what's up there. This one. All right, if I count the one that's there. Okay. Do you have an estimate count of how many squares are in your box or in your trapezoid? I counted and estimated the ones that were on the notes, and it counted out to be about 96 units. Just counting what you had on the notes, but you're counting what you've got. So count what you've got. You ended up with the same? Yeah. Okay. You drew the same as what that was? Okay. Okay, now then, I want you to label on your trapezoid. Notice how this one's been labeled B2 and B1. So your bases, I want one of them labeled B1, the other one labeled B2. Okay? And I want them labeled on the inside of the trapezoid because you're going to be cutting it out. So label them inside and label your height. Just like it's being labeled on here.
On the first lap table.
Okay? When you get it labeled, then cut it out. Once it's been labeled, you're going to cut it out. Do what, honey? I'd write my estimate in there. Okay? Cut the trapezoid completely out. I need a piece of graph paper.
You want us to cut it on the line?
I don't know. I don't really have scissors that I can loan out because I don't have a bunch of them.
Someone give you mine. I didn't get them.
That's why I ask kiddos to bring them.
Share.
Yep, I said cut it out once you've got everything labeled. We're going to switch it to that. If you were not here yesterday, you do have a quiz you are going to need to take. Okay? Okay, I'm cutting mine out too because I know this gets tricky and oh, nothing to be confused about at this point. You've drawn a trapezoid, you've labeled it, and you're cutting it out. That's not anything to be confused about. I have an 8th grader at home that every time I look at him, he says I'm confused before he even tries to do anything. Some of you, that's a learned helplessness. To just say I'm confused so somebody else will do it for. Learned helplessness. Okay, so you got your trapezoid, right? Everybody's got a trapezoid.
Yeah.
Okay, everybody's trapezoid cut out for different sizes, that's fine. Now then, here's what you gotta do. I gotta have that where it's showing, and it's still not showing. Come on. Hover cam. All right. Now then, you take your trapezoid, and on one side of your trapezoid, find the center of this line. Find the middle point of this line. You can do it by counting. If you know the height, can you divide the height by 2? Okay. Or you can measure. So like mine, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 11. I have 12, so my center should be 6. Maybe. Hang on a minute. I've got 12 and a half, so my center is going to be 6 1/4. Okay. Here's what I did. Here's what I did. I measured from here to here, and it was 12 and a half centimeters. And then I divided that by 2, and so this angle is 6 1/4 would be half of it. Do you agree? Okay. And I made a dot, so I know where it's at. Now then, I'm going to take my ruler from that dot and I'm going to draw a line. Do you see where that line's going to be?
To the top corner.
To the top left-hand corner up here. From the dot to the top left-hand corner. And if my dot's over here on this side, it's going to look like that. Okay? Either way is fine. And because I know you guys and I know how you think, I better do it from where you're at. New color. I don't know, because I just drew it. I didn't measure, I just did. All right, here's what it looks like. Do you see my line that I drew? I took the center of this, marked it, went from here up to the top corner. Everybody see it? If you're not seeing it, it's because you're not looking. Okay, everybody understand what we're doing there? Okay. Now, I'm going to cut along that line. I'm going to cut that piece off. What shape am I creating? Okay. Okay. I cut it off. You see it? Where it went, I cut it off. Technically now, I have a triangle and I have a quadrilateral. Okay? I have a triangle. Now, arrange these two figures to form a shape or a figure whose area you're going to be able to know. You're going to manipulate these. Manipulate these two pieces into a shape that you understand and know how to calculate the area for. It's kind of like putting together a puzzle piece. Put the puzzle piece together to where you see the shape that these two now create. Please stop blowing whatever with your paper and do what you've been asked. Nope. Nope. Yes, you did. Yes, you have, Millie and Zoe and
This? I have. Wait, this? Like this? Chicken like beast.
should be, yes.
Like this?
Only thing is, yours don't match. Why do they not? You want me to tell you why it doesn't match? Because that isn't the center of this line, so now it won't match.
Like this? Oh, yeah, it is. Chicken like beast.
Yeah, you didn't get the center of your line either, or they would come together. Look at this. If I take these two pieces, and I turn this piece upside down, and I've gotten the center, look what shape I now have.
A ramp.
AKA triangle, isn't it? Okay. Now, I want you to, now, if I have a triangle,
Oh, got it.
and if you notice, base 1 and base 2, do you agree?
Yep.
Okay, on this one, I can count my base 1 and I can count my base 2. Base 1 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14. My base 1 is 14. Base 2 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 16, 17, 18. Is 21. So, is it true? Hey, is it true that when I add those together, it's going to give me the full length of the base of this big triangle? So what's 21 and 14? What's 21 and 14? Come on, sixth graders. 21 and 14 equals 35. So the base of my triangle is 35. And the formula for triangle is 1/2 the base times the height. Do you agree? Okay. Now, we mark the height before we cut it out. And so if I go over here to where my height is, where it was marked, I can count the height, can't I? And on mine, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? So I've got 1/2 times 35 times 12. Well, half of 12 is 6. Do we agree? Is half of 12 6? What's 6 times 35? And I know you got your calculators because you know we're doing them. We can get them. We always can.
210.
How much?
The number past mine.
So the area of my trapezoid
Is 92.
is 210 units squared.
Let's go.
The area of this trapezoid is 210 units squared. How did we get it?
Base times like that.
How did we get the area of the trapezoid?
You turn it into a triangle.
Okay. What formula could we do from this? What formula could we write that will give us the area of every trapezoid we ever deal
Oh, base times height divided by 2.
with? What's my formula going to be there, Mr. Barrett? Okay, if it's base times height divided by 2, I thought that was for a triangle, right? But there's something wrong. On this, I got 2 bases. What did I do with those 2 bases?
Oh, base times base. No, yeah, add base times base. And then,
This is base 1. This is base 2. Do we agree?
yeah, base times
All of it together equals the base of the triangle, right? So my formula could be something that looks like this.
Okay,
The triangle by itself was 1/2 base times height, right?
yeah.
I don't know the base of the trapezoid until I add both the base 1 and the base 2. I have to know the total base. That's why when I cut it apart and I made that triangle, I had to add them both together to get the full base. Well, once I've got that, the formula is the same as that of the triangle. You have a resource page. Get your resource page out. On that resource page, I believe you're going to find 1/2 times parentheses B1 plus B2 times H. You need to label that formula trapezoid.
You already did.
You already did?
Yep.
Do you know now where that formula comes from?
Yeah.
Okay, I had my trapezoid, I cut it, I now have base 1 plus base 2, and when I do that side by side, all I have is a triangle. Okay, kind of an understanding of why that formula works. Okay, now we're just going to use it. We've done it, we understand why it works, we just use it. Okay? Whoa, that's not what I want. so not working. There we go, now I should be able to. Okay, when we use the formula to get the exact, we got 210, right? How does that, now you've got your own. You need to calculate the area of the trapezoid that you created. You counted it to start with. Now you have to calculate it and tell me, how does that compare to what you counted? True. True. Okay, well, let's look at this one. Let's go back to this one that we know worked, right? Bear, yours was the same as mine, wasn't it? And did yours line up? No? Okay, so I've got, wait a minute, turning back up here. Do 12 by 14 for me, please. 12 times 14. How much? 168. And then I've got 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 42, thereabouts. Okay, we come up with 210 when we calculated it. I estimated about 200. Is my estimate pretty close? Yeah, it really was pretty close. Okay, and that's what you just wanted you to do, is look at what your estimate was and look at what you actually got and how close were you. So many of you have gotten rid of it, thrown it away. We just might as well move on. Formula. You can now, yeah. Or in a minute. Let's go ahead with this. Throw those away in a minute. Sit down. Okay. The key idea is that formula. You have to know 1/2 times the height times the base 1 plus base 2. Anytime you see a trapezoid, this is going to be the formula you're going to use. We've played with it a little bit. Thank you for staying seated and waiting to throw things away in a little bit. Following directions, that's really good when you do that. And I'm not being serious. That is sarcastic. Okay? Because some of you aren't following directions and you need to. With that being said, calculate the area of the first trapezoid here. A. Somebody tell me what I'm going to do. You got a formula. You got measurements. How do I plug it in, Mr. Gay? The right angle is always what measurement? The height. Where it runs perpendicular to the base, it's the, so this has to be my height here. It's a trapezoid, it's got 2 bases. What are the 2 bases? 5 and 9. So this area is going to be 1/2 times 6 times 9 plus 5. And you have to write this on your assignment because this is showing your work. You know what the formula looks like. You have to show the work. Then you can use that calculator to get the final answer. 3 times the area of A? What's it gonna be there, Melissa? Could it also be divided by 2?
Yeah.
Would this also be a true statement? 6 times 9 plus 5 divided by 2. Yes, it would be the same. Your resource page isn't going to show it to you that way. So that's why we're kind of making sure that we think of it as 1/2 times. What's the area of trapezoid A? What's it going to be, Bryson?
42.
Bryson says 42. Do you agree? Only it's 42 feet squared. 42 feet squared. I totally agree with that, right?
Whoa.
Okay? What about B? What's the area of B? And I'm not going to write it. You need to know how to do it. So make sure that you show your work. You look at that, you're wrong. You missed something. Yes. Nope. Try again. Yes. Nope. Try again, you two. Nice job. Nope. Nope. Yes. Make sure what you put on. Okay. What do you have? Meter squared. Yes. 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 Okay, formula says what? 1/2 times 5 times 11.5 plus 8.5. And if you're going to use your calculator, you're going to be dealing with some decimals. You got to do some parentheses. You got to be able to put it in the calculator right. Okay, and that's an issue. I see that walking around. So grab your calculator, especially if you did not get 50 meters squared. Grab the calculator. You're going to start out by putting in 1/2. You're going to do the 1, and then you're going to use the fraction symbol for the 2. So you got 1/2, right? Hit the times button. Times the 5. Times button. Now, I need it to combine the 11.5 and the 8.5 before it multiplies it by anything else, because that's a combined measurement. So I need to hit the parenthesis button, and I'm going to say 11.5 plus 8.5, and then I'm going to close my parentheses up. So I've opened parentheses and closed it. Does everybody understand what I mean by that and know where those buttons are? Press the equal sign now. Now you get 50 meters squared. Order of operations, this thing knows. Now, if you put it in, like this, 1/2 times 5 times 11.5 plus 8.5, it multiplied these two, and then it multiplied the result of those two by this, and then it added this. you have to put these parentheses there. Because if you don't, the calculator isn't going to do it the way you want it to. So calculators are great if you know how to use them right. And you understand order of operations well enough to know what you've got to include so that these things will do them the way you need them to. Okay?
Why are these so much darker than that one?
This one's blue, those are black. It's the only thing I know, buddy.
Oh, no.
I'm sorry, but I don't know it any other way.
Yeah, it's blue.
Okay? Now, this is having it written like this on your assignment tells me you understand what you were doing. Okay? And if you get it wrong after you've written it like this, then I know it's a calculator issue. Okay? If you don't want to have to do those parentheses on the calculator, let me get rid of this, then you're going to want to use your calculator to do 1/2 times 5. And what do you get? 2.5. And then you need to figure out, well, what is 11.5 plus 8.5? It's 20. And then you could put in your calculator 2.5 times 20. And you're going to end up getting the 50. But if you do it this way, just make sure what you're putting, you put into that calculator. Okay? Couple more. We're just going to do them, and then I'm going to give you your assignment.
What we do this side.
I'll see you again on Thursday. Right?
Yeah. And hopefully,
That's when it's due.
hopefully, we don't have school tomorrow. Why not?
We have career day in the morning tomorrow.
We might not even.
Okay, let's do it. Tell me, what is the height in this one? What is the height in number 1? Raise your hand. Tell me what the height is in number 1. What's its height? It can't be 8 millimeters. Well, it could, but the problem with that is, on trapezoids, doesn't the height have to be perpendicular to both of the bases? Okay? And that's why I asked you to tell me about this one, because this one is setting different than what you're used to looking at, right? But the height runs perpendicular to the two bases. So what is the height in this one? What is its height, Isaiah? 4. Nope. Try again. Because 4 is not perpendicular to both of the bases. What is its height? David? 5. So I have 1/2 times 5. Base 1 and base 2, I've got 4 plus 8. Do we agree with that? Can I calculate it? Okay, I got it done. It's in my head. Connor, what'd you get, bud?
30 millimeters squared.
Nice job, Connor.
Good job, Connor.
30 millimeters squared, absolutely correct. Thumbs up, you got it. Thumbs down, you didn't. Okay? Now, I'm not telling you how to do the other one. You do the other one completely on your own, and then we'll see if you get it. Completely on your own on the other one. Write it on your paper, right? Here's the problem. Base, base. Height. This is a base, and this is a base. The height runs perpendicular to both of them. So it's what you plugged into was incorrect. Look at what you're calling your bases. Your bases, something else to notice, the bases are always parallel to each other. Parallel. They never ever meet. They're best friends that never meet. So this one's parallel to this one. Do you agree? That's how you know they're the bases. This is parallel to this. Those are the bases. Does that help? These two, now let me ask you this. Is this one and this one parallel? No, they're going to end up running into each other. So those two can't be the base. Is there anything parallel to this one? No. So if there isn't anything parallel and the height runs perpendicular to the bases, is it going to run into both of the bases? It's going to cut them both apart. Okay? So you got to know the base is always parallel to each other. With that being said, what is the area of trapezoid number 2? What is the area, Kinsey, of trapezoid number 2? 30 inches squared. Absolutely correct. Okay? Your assignment right there. Yeah, because it blacked it out, and I don't know why it does that. It never used to do that, but this year, if I don't open up every screen, it blacks it out when it's printed for some weird reason. Just a minute, babe. Now, what did you ask me? That would be great, because the quiz doesn't take a long time. It was short. You may have your calculator and your I don't think it recorded. Your calculator